Hey everyone, well, I'm back with another video about chainsaw bar rail closer tools. Since the last video I posted quite a bit of controversy for some odd reason on a very simple tool, simply for reconditioning chainsaw bars. I don't know what all the confusion and excitement is in some of the comments and some of the personal messages I've been getting about this. Some of you have been emailing me with all kinds of, I don't know, strange comments, personal insults, things like that, which we don't need to get into, and we won't. But anyways, getting on with it here. This is probably going to be the last time, or at least I'm going to try to make this the last time I'm going to talk about this, and we're going to set the record straight. We're going to go through it step by step once more, and anything that I happen to have forgotten to mention in the last or the first video and the last video that I posted about this, I will clarify this now in the third video about this chainsaw bar rail closing tool. Honest assessment of it, it worked, but it didn't work all the greatest as into how it came set up from the manufacturer when it's made. And the tool is a cheap Chinese import tool, so you can expect that there's always going to be quality control issues with these kind of cheap import tools. If you're willing to rework it and do a few simple little modifications, the tool could be made perfectly. The tool would be perfectly fine to use, and it's proven since I've gotten it in the past almost year. I've done several, probably a couple of dozen saw bars, both for myself and for a few friends. So it's safe to say that I'm now comfortable using the tool. And also some comments came in about the last video that I posted, telling me that what I had discovered or was doing to use the tool as a workaround from the manufacturing defect was wrong. Well, I didn't manufacture the tool, I didn't make it. So I was working with something that's a defective product to start with. It's a workaround for a problem that exists. If it would have been manufactured correct in the first place, I wouldn't have been doing this workaround or doing corrective action. To try and use the tool as such as it came from the factory would be a problem, because it is basically impeding or hindering the use of that tool for what it was original intended purpose. So anyways, I'll get on with showing what all the controversy is about. The tool in question is these chainsaw bar rail closers. To break it down in as simplistic layman terms as I possibly can, it is literally a piece of 1.5" by 3/8 thick flat stock with a piece of 1 inch by 3/16 flat stock, welded this piece to this piece in a T shape. Okay, I think we all understand what a T is. With a hole tapped and drilled through it. The handle is essentially a piece of rod or a bolt without the bolt head, threaded end. 2 holes drilled through the 1 inch by 3/16 flat plate, just ahead of the bolt. And these 2 little 1/8 holes have 2 spring roll pins driven into them. Now these act as a guide where your chainsaw bar rail, this sits like so, down on the chainsaw bar rail. Now this is your guide. Nothing wrong with this end of the tool. What the issue is, or what I had the issue with this tool, is over here. They have a little set guide screw over here that's tapped and drilled into the 3/8 by 1.5" piece of steel stock. And what that set screw does over here is controls the depth at where your bearings, where these closer roller bearings that roll on the bar back and forth, what squeezes your bar rails and closes them back up after they're splayed from use and wear. This little hole here for the guide screw is drilled too far ahead and too close in between the bearings. Now what happens when that little bolt is in here, it was rubbing up against the bearings and jamming the bearings. When you turn this handle here, this is the tightener that pushes this bearing. As you can see, it moves on a slotted slide. Okay, simple enough. This threads in and out. There's a closer handle or a pressure handle. This pushes on this bolt. And you can see the bearing moves back and forth. That's your adjustment. You turn this in, the handle, it pushes it in this way. It closes the bearing in tighter on the rail of a chainsaw bar. Like so. I think that's a pretty simple, straightforward explanation. Now what's happening, like I said, this little bolt here, when it's in here, is getting jammed up against the bearings. So now I've been getting all kinds of weird comments, people's own anecdotal suggestions of how I could remedy this. They're saying, put a longer bolt. No, if you put a longer bolt, it'll jack the tool up further, and what'll happen is the bearings won't make contact with the bar rail. It'll be sitting up over the bar. Another suggestion from somebody else that emailed me saying, well, why don't you take and cut some bushing shim stock and lower the bearings down? Then it won't rub on that the guide pin or that bolt. But why would you do that? Again, now all you've done is lowered the bearings down, and it'll ride lower on the bar, and it won't. It'll push the bearings further down on the bar, and you won't be on the rail. Now I don't understand what's so hard to comprehend about a basic, simple tool of two pieces of metal flat stock welded together with a couple of holes drilled and tapped. The issue that I've had with this tool is simply this hole is drilled too far, kind of offside and too far in. Now you say, well, why don't you just drill and tap another hole? I've looked at it, and when I measure it out, it looks like on camera that there's enough room, but if I was to drill or tap another hole to move the bolt back away from the bearing so it wouldn't interfere, what happens is it would break through the edge of the plate. Doesn't look like it on camera, but actual measurements of a tap and die that I put on here, there's not enough room. Somebody else says, well, why don't you just weld the hole shut and re-tap it? Well, if you've had any experience doing any welding, if you put a bead of welding in a piece of iron stock like this and then try and drill and tap that out, chances are you'll break some drill bits or worse, destroy your tap. I've priced out an actual decent quality name brand tap that could do the job, but the cost of the tap is actually more than the cost of this whole tool. So what I've done is simply this little guide bolt or depth bolt out. Now I was told I was wrong, saying you're going to wreck your saw bars by doing that. How? If this tool sits too far down on the rail, all I'm doing is I'm not actually would be in contact anymore with the proper depth. If I drop down further, all I'm doing is just pressing or rolling on the main bar itself. Now this is just a simple small hand tightened tool. This isn't like a 50-ton press. I'm not going to destroy the saw bar simply if I'm a little too deep down. Now when I'm pulling the tool along the rail, when it's set over here at the proper, like I say, you set this one, so when it's set at the proper depth, this end of the tool here, when you're pulling it on the rail, the bar rail, actually self-aligns. It doesn't drop down and going like this. It planes out on an even horizontal plane, and it pretty much, it follows where this point is, this follows. Plain and simple. And like I say, if it drops a little too low over here, you're not doing any damage. Now what one guy was suggesting is telling me that it's way easier, like I said, just to, he was saying just to roll the very upper top edge of the rail. Don't roll the whole depth of the rail. No, where the groove in the rail is, you want to get the full depth of this, whether it's 3/8 of an inch or 1/4 inch, whatever bar you have. Some bars are deeper, have a deeper rail groove than others. This is not new news. I was told this a long time ago. What happens if you just roll the very lip or edge? Look at it this way. You have your rails. They splay out like this with time and wear. So what you want to do is bring them back square like this. But what happens if you're rolling just the very tip edge of them? It'll go like this. So what'll happen is you'll end up with a bowed effect, and you get all your wear just right on this top edge. And what usually happens is they splay back out pretty quick within half a chain's use, and the guys say, well, these tools don't work worth crap. You do have to roll pretty much the whole depth of the groove, not just the very lip edge. You also run the risk of cracking or breaking chunks or chips off of them, kind of forcing the upper lip edges. So anyways, like I say, I think this is pretty much about as simplistic of an explanation as I can get. I don't know what all the controversy is about a simple bar rail closer tool, but I actually had to delete some comments simply because of the nasty nature that this was taking, and also some of the weird personal messages I was getting of people not seeming to understand how the principles of this work. Telling me that I should lower the bearings and put a longer bolt. Well, it's not an issue of vertical on the bar. It's of where this depth screw was placed on horizontal, too far in and too far to one side. Not vertical alignment of the tool. It's where the locating depth pin bolt was located, whatever you want to call it. The depth pin, depth bolt, screw. It's this little bugger that's too close to the bearings itself. That's why I just removed it. It's a quality control issue. If somebody has an issue with how these tools are made, take it up with the manufacturers in China. Don't get on my back about it, people. I'm just presenting, I'm just showing a basic factual tool that does the job. I've done, like I say now, probably dozens of saw bars. They're all working just fine. The biggest modification I've done to this tool so far is just simply removing the bolt. It has saved me a whole bunch of grief. Whatever you want to do, if you want to go and buy special machine bolts and spacer stock and start whatchamacallit, go ahead. All you're doing is lifting and lowering the principle of the tool. It doesn't change the fact that where this locating dowel or bolt here is drilled too far this way and too far the other way. Lifting or lowering the tool or the bearings themselves doesn't change that metric of what's wrong with it. So, like I say, I think I've explained myself pretty straightforward here on this video, and like I say, I think this is going to be the last one that I'm going to talk about this. So, anyways, once again, I'd like to say thanks everybody for stopping by and checking out another one of my videos, and we'll see you all on the next one.